Hello, everyone, and welcome back to another episode of the Jack Westin MCAT podcast with your hosts, Mike and Molly. Mike, I'm excited for this episode. Shocker.
Shocker, another exciting episode. Oh
I
no,
know.
Molly's excited for another podcast. It's you know what? And rightfully so. Rightfully so.
Rightfully
Everybody
so.
does it.
You know what? Every episode is great, but this one is particularly fun because one, it's the start of a little series that we're going to do, and two, it's a great culmination of the things that we did in the last two episodes,
Mhm.
right? If anyone did not listen to the last two episodes, we had MCAT math, and then we had forces, energy, and power. So we had MCAT math, and then we had a physics content lesson where we were talking a lot about how effectively to do math in that realm. Today, we're going to talk about a broader topic that ultimately builds on all of this, right? What are we talking about today, Mike?
We're going to be talking about mastering the ChemPhys section, specifically passages and how can we actually master those ChemPhys passages. We're going to be building off of the strategies that we talked about in a previous episode. If you haven't checked it out, we did a whole episode on science passage strategy where we broke down in general how to take
Mhm.
on any science passage. But today we are zooming in, we're kind of
And
locking
science
in.
question
And
strategy.
science question, we did
We did an
another
episode
episode
on that too.
a
Yeah.
whole separate, and that was also we're also going to build on that today, but we're kind of like zooming in, we're locking in, we're going to be doing this for every section, but today is the chem phys section
Mhm.
because we know students struggle with different areas, right? Like some
Yeah.
students bio, that's their strong suit, that's great. Psych soc, they do fine, but maybe chem phys, they struggle with that. Maybe it's the other way around. We're going to be
Yeah.
speaking to each section, the difficulties, what you can expect to see, common, struggles and mistakes that we see, and also how to navigate them, right?
Yes.
And I don't want today, we're going to be talking about like different types of passages that you're going to see in this section. I don't, again, this is maybe my view of it. I don't want anybody who listens to this try to memorize everything that we're going to say
Yeah,
today.
definitely not.
Don't try to memorize everything we're going to say. But really, if you recognize there's an area of concern, you always feel like, oh, there's a certain type of passage that you
Yes.
struggle with, right? Like if we're
Yes.
going to be messaging a few times, if there's like, oh, I know I struggle with those passages, take a listen, kind of like burn the volume up on that kind of section of the
Yes.
podcast, because that's where you really want to be focusing on, because we're going to be speaking to how to navigate those specific types of passages. But where I'm
Yeah.
getting already ahead of myself, but yeah, I'm very excited because this is an area that I know a lot of people struggle with.
Yeah, and I feel like it's super valuable to go through it this way and go section by section because ultimately, as we talked about in our passage and question episodes where we're more general, you really have the same set of tools for all of your science sections. And even a
Mhm.
lot of those same tools apply to cars as well, although that's a different realm. If you want to learn cars, check out our other weekly episodes that I do with
Right.
Jack for the cars reading skills workshops. Those are pretty fun, but ultimately with science, right? Again, every science section, it's unified by the fact that you've got content coming in from outside, right? Your own background knowledge, but also there are a lot of similarities in types of passages, ways that different skills are tested. Ultimately, you're going to see data interpretation in all of them. You will see new information, new terms, new molecules in all of them. You'll see, non-data figures, things like, reaction schemes or molecular diagrams, etc. Like what we want to focus on in a video like this or an episode like this is how are those same general things going to show up for chemistry and physics,
Hmm.
right? So again, like you said, we're going to get more in depth into specific, I like to call them passage personalities.
Uh-huh.
It's
I love that.
you will see so many things that you have not seen before on every full length that you take. That being said, as you get more acquainted with MCAT passages, as you do more practice questions, practice passages, full lengths, things like that, you're going to start to see some repeating themes.
Mhm.
And that's really what we're going to talk about today. So, whenever you sit for chemistry and physics, right, these are the things that you can expect to see. Now,
Mhm.
usually when we have episodes like this, we kind of start from like most of our listeners probably have a basic idea of what the MCAT is like. But just to be super clear, because we're going section by section, know that like all other science sections, you're going to have 59 questions to do in 95 minutes. You're going to see 10 passages in that, and then 15 discrete questions. Okay, all the other questions are going to be associated with passages. So you will have standalone questions that, obviously will be completely divorced from a passage. They're completely on their own, but the vast majority of the questions you're going to see are paired with passages. I think a lot of people know that, but in case that's news to anyone, it's valuable to know because ultimately you are graded based on the questions, right? Like your questions determine your score, but in a passage setup, a lot of the answers to those questions come from the passage. So you really
Right.
need to understand both and be ready to join them. Oftentimes,
Mhm.
the things that hold students back is I'm just going to look at the question. I'm going to skip the passage. I'm going
Oh,
to,
oh,
completely
don't
ignore
do
it.
this.
No, no,
Yeah.
no, please
Hmm.
don't. You need to understand both. So we're going to talk about both today in the context of ChemPhys. And because, you read the passage first and then you go to the questions, I feel like that's a good place to start. So
With the
maybe we could
passages.
think passage personalities, right? What are we going to see? This is
Mhm.
the first section of the exam.
Hmm.
What's going to
What are we
happen?
expecting? And it was
Yeah.
so interesting, like going over these personalities with you, Molly, like before the episode, because it was so great to see, like, we were talking about the exact same personalities. We'd actually never like talked about passage personalities before we prep, but we're like, oh, how about this type of passage? Like, we were like in full agreement about every one of these passage personalities, which I think really speaks to like between you and I, we've done thousands,
So many,
thousands of
so
passages.
many.
So it's so interesting to see, like, yeah, they really all fall under these certain categories. And it's really interesting because when you become familiar with them, you can start anticipating what's going to come next in these passages. And I think the
Mhm.
first really common ChemPhys passage personality is the physics setup one, right? Where
Yeah.
you have a topic that's related to something about fluids, forces, circuits, something with like light or optics, where it's a very physicsy passage, right? These often start with
Mhm.
like a scenario like, oh, we have a patient on a ventilator, or we have a lens system set up, or we shined a light through it, or we had some sort of a laser situation going on. In this, we've set up some physics scenario to demonstrate some property, something about waves, something about light, something about pressure and fluids. Right.
Mhm.
And in these sorts of passages where we're kind of, it's some definitely a lot of that physics content, there's going to be a lot of data associated with these, right?
Yeah.
Where they're going to do some experiment where they're like, oh, we wanted to test the rigidity of this thing or the stress and strain across this thing. So we did this experiment and here's the results. Here's this data around it. And now here is where we want to kind of outline what's really important for a passage like this
Mhm.
is the data. I want to make this very
Yeah.
clear, and I want no ambiguity about this. We never skip the data. We
I
never
know.
ever skip the like I know I've heard this so often, all right? We talked about this in our passage strategy video and a little bit in our question strategy video as well, where we hear students all the
Mhm.
time say, "Well, I heard on Reddit that I'm supposed to skip the passage and then or skip the figure. I can read the passage, but skip the figure, and then if the question asks me about it, oh, to go back to it." Here at
Mhm.
JW, Molly and I, we've seen this so often. We do not recommend doing this. There's a few reasons why, but here's kind of some reasons that I believe that you should not be doing this. I think one, a lot of the times that data is going to be in the middle of the passage, and the rest of the passage relies that you understood that data. And so a lot of
Yeah.
times we skip it and then we continue reading and we're like, oh my goodness, what's going on? I am now lost. Oh no, stress, cortisol, right? So because we didn't skip, we skipped the data. Also, though, a lot of times these questions don't owe you very much. I like using this wording where the AMC doesn't owe you that much. There's some things they do, but a lot of things they don't. They don't owe you to say clearly, oh, this is, you can find this answer in the data. They don't owe you that. Sometimes they'll say in the questions in table three, in figure three, hey, that's them being nice. But there are so many questions. And we even do one in our science strategy free trial session where there's a data-based question, but there's nothing in the question to say, hey, look at the data. But you
Mhm.
would only know the information's there in the data if you'd already gone and looked through it, right? And
Yeah.
so I think those are always my kind of two of when I'm trying to convince a student, like, hey, stop skipping the data. Those are usually I'm always attacking with like a very logical reason. Don't skip it, actually read through it. But on the other hand, we don't want to stay all day at this. I don't want you sitting there for 3 minutes looking over this data. We actually have a strategy for interpreting data
Mhm.
that anyone who's listened to our science passage strategy video knows and maybe recalls. If you haven't, that's okay. We're going to go through it now. And that's the TAUT method, right? Honestly, Molly, you and I, we love the TAUT method, but I think a lot of students hear the TAUT method and they think they're doing it right. But a lot of times we see common mistakes with the method. So Molly, walk us through like what is TAUT? How do we use TAUT? Like what is this? Why do I keep saying this word over and over again?
So if you are going to be doing a research figure analysis for the MCAT, and this is true of all sections, a lot of students get overwhelmed, right? Like,
Mhm.
where do I even start?
Mhm.
Oftentimes you're coming out of some pretty complex paragraphs, and then you just see a table, or maybe it's a line graph or a bar graph. So the first T in
Mhm.
TAUT, it's TAUT. The first T is for the title.
Mhm.
Okay. A lot of students, especially for the title, they just skip it. Right? They're like, this is not going to tell me anything new. The title's incredibly valuable because it's going to do one of two things. One, it could give you brand new information. Okay. It could give you information about something that has not been mentioned before, something
Truly.
like statistical significance. But I've also seen them give other information that's necessary to understand the diagram that is not in the passage. Okay, so that for that reason alone, read every title. They do not have to tell you that there's something special in the title because they've given it to you. If you choose to skip it, you might miss out on that. There's not always new information. If there is not, it is still worthwhile to read the title because the other thing that it can do for you is essentially restate your research question. Oftentimes it'll show like the effect of this on this. That's your independent variable and your dependent variable, respectively. It's a great way to nutshell what was told to you in probably a pretty complex way somewhere in those paragraphs that preceded it, right? So it's a great summary of what you're about to see. Okay, so if it gives you new information, that's critical. Make sure you get that, right? And if it doesn't, at the very least, it's going to help summarize what you should be expecting to see in that figure, which is really helpful. Okay, so T, first T is title, right? Then we get to the A and the U. That's axes and units. Okay, these two really go hand in hand, right? Because ultimately the axes are going to tell you the variables that you're expecting to see. Oftentimes the x-axis is going to indicate our independent variable. The y-axis is going to indicate our dependent variable. And then, of course, right next to the actual variable itself, you're going to see the unit that they use to measure that value. These are important to recognize because, again, it's helping you understand the information and the data that's going to be presented when you start looking at the final T, which is trends. Okay, and I want to be super clear here. For the vast majority of data interpretation questions, the trends are going to be what they're going to ask about. Every once in a while, you'll get a question like, what is the independent variable? In which case, hey, that's why we do TAUT, right? The title will help give you some context. And then, of course, the axes will be important. If you get a calculation question, maybe the units of those axes are really critical, right? You need to know the units to do calculation. But vast majority of time, they're going to ask you about the trends. Okay. That being said, can we skip TAU and go straight to trends? Sure, that would be lovely, right? It's almost like you're asking, though, can I snap my fingers and materialize at the top of a set of stairs? Like, if you could, that would be
Be
awesome.
nice. Be
Like,
nice.
more power to you. Like, you need to get to the top of the stairs and you don't want to walk up. That would be great if that was an option, but you can't, right? TAU are the stairs that help you get to the trends, right? They, in and of themselves, are not always critical, but you cannot get to the trends without first establishing the baseline, right? So for students that are like, every time I look at a research figure, even if I'm using TAUT, I get so nervous about it that it takes me 2 minutes to figure, no question. I understand, right? Practice will help, but also what I would communicate as like the bare minimum, right? Because you don't want to ever just skip a figure. At the very, very least, let's say you're in a time crunch or you know yourself and this figure is terrifying you. At the very least, give us TAU. Do
Minimum.
TAU. It really should only take 10, 15 seconds to do TAU. You read a title and you look at the axes. Like Mike was saying earlier, they do not owe you a in figure two in a question. They do not have to tell you where in the passage you should be looking to get your answer. And that's really difficult because they could ask you a question about the data without telling you it should be from the data. They might say in the passage. They might just not even tell you anything and just ask the question. If you don't know what information is contained in that data, you will never know to look at the figure. Okay, so it's absolutely critical. You need to know at the very least what is there, right? If you don't know what the important finding is, when you move to the questions, that's okay. But you need to know enough to recognize that a question is asking about the figure. And then at that point that you realize, oh, this has something to do with figure 2 or table 1 or whatever it is, now you can go back and finish out the T, the final T, the trends. And then you could still get the question correct. It is best practice to do the full TAUT before moving on to the rest of the passage. But for anyone who might be hesitant for one reason or another, right? TAU is a must, right? It is critical, and that alone can really help you on the majority of the questions. And it doesn't
Yeah.
take that long, right? So if you're in a physics setup and you've got complex data, again, there's a lot going on. I know a lot of students get very scared of physics-based passages, but one other thing that I want to mention, just because we're talking physics and because I know it's a scary pain point for a lot of people, I know that the name of the section is called chemistry and physics. I would be thinking to myself, 50%
50-50.
chemistry, 50% physics. We didn't mention this earlier, and I feel like maybe we can now, right? This section, in terms of questions asked, is actually only 25% physics. Okay, so it's 25% of 1/4 of the test. It's a pretty small number of physics questions. Does that mean that you need to, or that you shouldn't learn physics? Of course not. I would put it as kind of a medium yield subject, right? It's still a fair amount of questions, but not every passage is going to be physics. For anyone who's scared of physics, know that it's 25% of chemistry and physics. More important, right, is actually general chemistry. That's 30% of the exam. We're going to talk about that in a sec. You'll also see 25% of it, even though this is tested in another section, 25% of chemistry and physics is actually biochemistry. You might be thinking that's for biochem.
That's
No,
biochem. Yeah.
it's ChemPhys too, right? So it's 30% gen chem, 25% biochem, 25% physics, 15% OChem, so a smaller chunk even than physics. And then you will see a tiny bit of bio. This is for the questions, but again, I feel like it's helpful to understand that context if we're trying to figure out how best to approach chemistry and physics. So
And
that's what
these
we could
numbers,
expect.
for reference, come from straight from the AEMC. Like they
Yes,
release like what slice of each section is what percentage. And yes, this, like you're saying, is in the questions. They don't owe the same for the passages. And because a lot of
that's what I
people,
was
like
gonna
when
say.
they, yeah, like a lot of people say like, oh my gosh, my exam was a lot of low yield content. Oh my gosh, it was like all physics. Well, the
Yeah,
passages might have things to do with physics in them. You're totally right. They don't have owe you those, but the questions themselves
yeah,
must. Kind of like we were
yeah.
talking about things that the exam doesn't owe you, like in the questions, they do owe
Mhm.
you that. Like that's kind of
Yeah.
they have to follow those rules where they can have a physics passage, but then like it's all mostly chemistry questions.
Gen chem. Yeah,
Like yeah.
exactly. Yeah.
So that's like one thing to kind of keep in mind, especially because I hear like a lot of people, they're like, oh yeah, people on Reddit are saying the exams are more and more this
Physics
subject
heavy
here,
or more
physics.
chemistry heavy. Yeah.
No, it's the
There was
same
so much
percentages.
OChem on my exam, and it's
They're
like, yes, but not the questions.
not the questions, like the passages. So keep
Yeah.
that in mind when you're going through the questions and when you're studying, right? And I think knowing these percentages is very important, especially when you're self-assessing, right? When
Yes.
you are trying to figure out, okay, what areas should I improve? I know I'm just kind of stealing this example from you, Molly. But like, say you are struggling with both amino acids and something like, oh, let's say like orgo, for example.
Electrochemistry. Yeah.
Yeah, or mean, I would choose even a smaller slice, right? Like
Yeah.
say on amino acids, you're like 75% on amino acids. You're like getting 75% of the questions right, but you're getting like 50% of orgo questions right. You would think based on percentages, oh, you need orgo more. But
Mm,
those orgo questions is like 5 questions, where the amino acids questions were like 15 questions,
yeah.
where it's way more important to master amino acids because there's way more testable material on things like amino acids. Whereas orgo, while you were lower in percentage, is not going to come up as much. So it's not as worthy of your time. This is really important when we're like dictating where we should be focusing in our study plans, especially when we're talking about the sections. Not to say orgo's unnecessary. No, no, I'm not trying
Yeah.
to say that, but in terms of priorities, like it just kind of like in medicine, in the ER, you have to prioritize the thing that's most pressing. That's a good
Mm.
way to prioritize it.
Yeah. And I also feel like while we're off on this sort of tangent with deciding what's important to study, I also feel like there's something to be said for how difficult that material is for you to master. Like in your situation with OChem versus amino acids, if you, again, you might see a greater number of questions correct if you dedicate that time towards amino acids. That being said, it also takes you many students, especially because the scope is much smaller, it would take a lot less time to get up to a higher accuracy and increase the number of questions you get correct in amino acids than in OChem. If OChem is very difficult for you to learn, again, not to say that you shouldn't learn it, but that should not be your first line of what you're going to act on, right, to improve your score. If you put, let's say, 3 hours towards amino acids, you could see a very significant improvement in your score, right? If it's just been a while since you've seen them, right, but you've already learned it, compared to OChem, let's say, you struggled in your courses and it's been 2 or 3 years, you might need 20 or 30 hours to fully master OChem. It's obviously there's a lot of material in there. And if it's harder for you to learn, you're going to need to spend more time on it. Again, not that you shouldn't dedicate time towards OChem, but especially because I know a lot of us are either, it is September 9th on the day that we're recording this, a lot of us are either about to take our test, right? Or we are going to test in months. Okay. So either we need a quick boost in order to get to our desired test day, right? Or we have a long time. So being intentional about where you spend your time is very important on either case, right?
There's no situation where you don't want to be prioritizing.
Exactly. It all comes back to intention.
I knew you were going to say the word. I knew you were going to say it. Well, so I love this kind of tangent. You can tell that we both love okay, this is what you should know. This is what you.
I know it gets important. It gets important,
right?
but
so I'm going to bring us back to
physics, yeah.
on our passage personalities. Coming back, reminder, if you recall, we were talking about our physics passage, our physics setup, where it's like an experimental setup, a lot of data. Make sure to be using TAUT. Molly put it wonderfully. How to use the TAUT? At least do T, A, and U. I would usually recommend, and because this is what I usually recommend to students who feel like they're like, oh, the trends, like I don't really. Try to pick up the trend in like 5 seconds. Like look at quickly, is there a trend? If there's like, it's not immediately obvious. Like if there's a table, for example, and there's like numbers everywhere, and you don't pick up an immediate trend in like 5 seconds, move on. Just go.
Yeah.
Right. But at least do T, A, and U. And I think this is also really important to do because I know there's some people who are listening and be like, I don't need to do TOTs. I don't need to do that for pass. I can read them fine. But then they find they make a lot of like silly mistakes, right? Like, oops.
Don't say that term.
I know.
No silly mistakes.
It was gross for me to say it. But we say, oh, I make a silly mistake. But if you remember I think we mentioned this a lot in our question strategy. There's no such thing as silly mistakes. There are real mistakes that we can fix. And a lot of the times, the fix that we need to do is we have to change our process. We give ourselves too much leeway to make these silly mistakes. No, it's usually a procedural issue. You have to change how you do it. If you find, oh, I mess up units, oh, I missed that, oh, it's micromolar instead of nanomolar. No, you need to proceduralize it. Add that you are going to check your units in your game plan. Don't just trust that you're going to remember to do that. No, add it in the plan. This is why formalizing these steps and really structuralizing, I think, has so much highway for improvement for so many people, even though it's such a I think both of us agree it's such a simple fix for so many people. So in our physics setup, make sure to be looking at your data before you look at the questions and making sure to keep track of your units and the variables that are associated with those units and relationships before looking at those questions, because that's really testable in those sorts of passages.
Yes, absolutely. And of course, get practice. When you're done with the passage itself, look back, ask yourself what parts of this passage ended up being really important for the questions. You will see that these same trends that we're talking about are the ones that are in most passages, right? These are the things that are most important to pull out. Let's talk about another type of passage personality, right? So we had physics and heavy experimental setups. Again, lots of probably numerical values with units. We've got diagrams, we've got data, all this stuff. What about kind of on the opposite side of the spectrum? What if we had a general chemistry experiment, right? In that kind of passage, you might also see an experimental setup. You might also see values with units, but of course, this is going to look different, right? Think of the things that you did in your Gen Chem lab or your OChem lab, right? You'll probably be doing things or describing things like titrations, right? You are adding acid to neutralize a base and calculate its concentration. Or maybe it's electrochemistry experiments where you have a physical setup with an anode and a cathode, and maybe they're asking you, the experiment went wrong. What did the student do wrong? Or, how are you going to interpret this particular trend that is found, right? You could see things with kinetics and rate laws, right? Like oftentimes you will see Gen Chem in the context of experiments, but similar goals, right,
Hmm.
for our physics, right? Again, if you have lab setups, you have different, procedural equipment that's being used, you're adding specific concentrations at a particular volume of this reagent to a beaker, and then you add this particular reagent at this given volume, at this given concentration, what's going to happen, right? The numbers are very valuable to keep
Hmm.
track of, as always, but you should really be ready to do calculations
Right.
anytime that you're in Gen Chem experiments. Maybe you're doing a percent yield, right? Maybe you are calculating to find which is the limiting reagent. There are lots of things that they could ask about, but when we see Gen Chem experiments, that's often what we see. And you can see this in combination with another type of passage personality where you've got a reaction scheme. Sometimes
Hmm.
you'll see those in our Gen Chem experiments, in which case we've kind of blurred lines with OChem, but sometimes you'll see that as well. And again, maybe the questions, a fair amount of them will come from data, but if there are any sort of reactions that they're describing that you are understanding in the experiment, that's also fair game. Okay, so we need to be ready to understand concentrations with volumes, right? Molarity, molality, all those good things. We need to be very comfortable with dimensional analysis, right?
Hmm.
Making sure that we are canceling out, right? Multiplying or dividing in order to change the units in the direction that we want to go. Stoichiometry, right? These are all things that you should expect to see and be ready to see. Keep in mind, Gen Chem is even higher yield within ChemPhys than physics. So
Hmm.
expect to see a couple of these sorts of passages.
Right.
And again, sometimes we see this kind of middle ground between this and our next type of passage personalities, right? Which is really the OChem side of things.
Right, right. OChem, that's what you're going to see. And this is where I remember when I would see an OChem passage personality. I didn't realize, I remember this was when I was studying. This was almost 5 years, over 5 years ago now. When I would see this personality, I'd see an OChem structure and I would get like heart palpitations. I was like,
Yeah.
oh no, Orgo. But really, after looking at it now and doing so many of these passages, they're never really that bad. Like a lot of
Mhm.
people are afraid of a lot of these topics in OChem. But a lot of these orgo chemistry applications, these orgo personalities, really just hit on the basics. All right, these are the kinds of passages that have a bunch of reaction schemes where you see all of these structures and it goes from, hey, this structure, and then arrow, maybe some reagents, then another structure,
Mhm.
arrow, then some reagents, oh, then another structure. And we're like, oh my gosh, I've never seen this reaction before. Sit
Mhm.
down, take a second, right? There's kind of some key things to be paying attention to in these sort of reactions. To kind of note before I get to kind of the key things that we see, we might also see some spectroscopy situations where maybe we're identifying a certain molecule. This is where you're going to see like NMR, IR, UV vis, right? These spectroscopy techniques to identify them also might come up. But what we really want to be focusing on in these orgo passages is what you know. Don't feel like you have to memorize a whole bunch of different reactions or like, oh my gosh, this is a whole new reaction. Do I need to have known this really
Yeah,
niche version of the
definitely.
reaction? No, absolutely not. That's like 99% never the case, right?
Yeah.
Simply just focus on what you do know. Right, when you're
Mhm.
seeing a reaction, my kind of always piece of advice is just look at what's different. Because it's not usually the whole molecule that's changed. It's usually like a big molecule, and then there's only like a functional group that's changed. Like, oh, this
Mhm.
functional group went from a carbonyl to a carboxylic acid. Or, hey, we
Mhm.
had an alcohol here. Oh, and now that's an ester or something along those lines. Like,
Or
look for
ketone,
like it's a ketone now. Oh, interesting. Oh, it's actually gone the other way around. Like, no, these are these little functional group changes. That's what we focus on. Don't get so lost in the sauce and like, oh my gosh, I don't know it. Focus on you do what you do know. Don't memorize every reaction, but focus on what's changed in these reactions. And that's what the questions are really going to be asking, right? And also really linking to that, notice what's changed, but notice what did we add in order to cause that change? Did we add, a certain oxidizing agent, a certain reducing agent? Was there an acid or a base being added? Use that as your hint, but don't think, oh, they've given me this really niche. I'm gonna make a Waldol reaction. They're gonna really change the name there. Waldol reaction, and then you're like, oh my gosh, I've never heard the Waldol reaction before. No, you probably didn't need to before, but that a lot of times we get stressed because we haven't. But normally, just focus on what actually changed in the reaction.
Yeah, and I was one of the students, one of many I
Hmm.
know that was really really nervous about the OChem component of the MCAT going into it. And I had heard that it was lower yield, which I was very comforted by. But again, just because OChem is only 15% of ChemPhys does not mean you can't get OChem passages in more, right? In more than, let's say, one passage, right? And I remember right before my test, I had been kind of fighting off OChem with a stick. Like, I just don't want to deal with it. I don't want to deal with it. And right before my test, maybe the last 2 or 3 weeks, I was like, you know what? Like, I'm just worried I'm going to get a passage like this early on my exam. I just want to get comfortable with it. And it was very eye-opening to really dive in deep, specifically with OChem-based passages, because I am trained from my OChem undergrad. I need to know arrow pushing. I need this. I need that. You could take an MCAT OChem passage and ask some really gnarly questions about it, but they don't. They don't ask you about the really gnarly stuff that they would test you in undergrad. Like OChem in particular is not tested the way that it is when you are taking OChem coursework. And I'm really glad that I did that, and kind of, just exposing myself, I was able to mitigate some of that fear that I had of OChem, because guess what? My very first passage was in my real exam.
Obviously,
Passage number one
had to have been an OChem passage. Yeah.
was this gnarly passage with this like 10-step reaction. I was so overwhelmed. And then I was like, wait a minute, I've done these before. Like, even if OChem is not my favorite, even if OChem is not my top scoring question subject, this question or this passage probably does not have 5 or 6 OChem questions. It's probably 1 or 2 OChem questions with some physics and some gen chem. I can do that, right? And ultimately, right, like, those passages are not the worst. Okay. Even if you hate OChem, I encourage you, go on our website. We have a free Q bank. Try fundamental passages within organic chemistry, and you're going to be surprised. Okay. On our Q bank, fundamental means topic specific. It's only going to show you OChem passages. You can even narrow it down further if you specifically want functional group chemistry or reactions or whatever, but just try some OChem stuff. You'll start to see the passages look really scary, but the questions typically are not that bad, right? That was really helpful for me on my real test, but I feel like it's valuable to get practice with all of this, but especially if you are scared of something specific.
Yeah. And I think that kind of emotion that when you're scared of something, you avoided it like the plague, is a lot of times reinforces the idea like, oh, I can't do that thing. But as soon as you actually like do it, and you actually believe that you can, you find it's never usually as bad as you thought. Well, I do this a lot with like tutoring students, where when we work through something, they're like, oh, this was the worst thing ever. I can't believe it. But when we actually walk through it, it was never really that bad. A lot of times it was our own fear that actually made the question so bad. But when in reality, when we looked at it objectively, it was well within our grasp. It was well within our ability to do. There was rarely ever any questions. There's like 1 or 2 questions in some of the AMC exams that I'm like, okay, yeah, that's a pretty tough question.
Yeah.
But like the other over 200 of them are all pretty straightforward. We usually just overthink it. That's usually the answer always. And maybe there's somebody like, oh yeah, I always feel like I overthink the question. Yeah, it's a lot of times because of our initial reaction to it that we built it up to be this big thing.
Yeah, we have a lot of preconceived notions in our head about what is difficult for us. That's why we always say, let the data help shape your decisions on what to study and what to work on. Let the data do it. Am I missing questions in this? Maybe you hate OChem, or maybe OChem scares you, but maybe it's not the section that you missed the most questions. Maybe you're actually struggling more in Gen Chem, even if you like it, right? It's easier to you in your head, but guess what? You're actually struggling more with those questions, right? Let the data lead you in the right direction when it comes to spending time on things. And in the realm of very high yield, important things to focus on, right? To kind of more or less round out our passage personalities, we've got our really biochem heavy passages, right? Yeah. As we've talked about, obviously you're going to expect to see biochem in biochem, right? Which is another science section, of course. But biochem is 25% of chemistry and physics. So not everyone realizes that you can see essentially the same type of passage in biochem and in ChemPhys, right? Because if it's a biochem passage, right, that belongs, it could go in either section. So you're going to see similar types of passages every once in a while to what you see in biochem. You'll see things on enzymes, enzyme kinetics, amino acids, metabolism, right? Oftentimes they are connected with experiments. We're pretty trained by that, but you might see protein mutations, even gene mutations that obviously have consequences with protein structure. You could see, determining Lineweaver-Burke plots or Michaelis-Menten. These are things that you might be thinking, that's biochem. No, it can be here too, right? And the same strategies will apply. We will actually be doing an episode in the next couple weeks on how specifically to approach biochem, the same way that we're doing here with chemistry and physics. But this is an area of overlap, right? And there's actually a lot of overlap between especially ChemPhys and biochem. This
Very
is a
much
very
so.
obvious example. When you're doing these types of passages, one of the things that's the most overwhelming is they're going to throw a bunch of molecules at you. They'll throw a bunch of relationships at you. They'll tell you this is mutated from a serine to an alanine. What's going to be different, right? You're going to have to connect the dots. What can serine do that alanine can't, right? Serine can be phosphorylated, alanine can't. Maybe phosphorylation is important here, right? Like it's so overwhelming. It feels like, drinking from a fire hose with all these new terms and relationships. The one key strategy I would tell you is use your scratch paper. Okay.
Please.
If you feel like you're drinking from the fire hose and you've got way too much information, can you draw a sketch, something that will help you recall the relationships between these molecules or any sort of visual to help you organize this new information? That makes the biggest difference. And oftentimes students are like, that takes too long. The best case scenario is actually to make them while you're reading, right? It shouldn't take long because, and I always say this with cars, but it's true of any sort of visual or note that you're making. You only need to understand what you have drawn or written for, like, in the sciences, like 7, 8 minutes, right? Like it doesn't need to be something that's beautiful and perfect that you could be turned in for an art show. It doesn't even need to be something that makes sense in 20 minutes. Like do whatever you can do to help just get your thoughts organized, especially when you feel overwhelmed by information. Make a visual. Okay. It doesn't have to be perfect. In fact, it shouldn't be perfect. But if you can do it while you're reading, just to give you a sense of what you are reading and organizing, you can combine this with highlighting, or you could even use that as your anchor instead of highlighting. Although, of course, we haven't said it yet. Highlighting is valuable in all sections.
But
We talk about that in a
in a very
general.
intentional way, in a very
Yes.
intentional way, yes.
Yes.
Yeah. And
Calling back to passage strategies.
sure. Yeah. And I
Only
think
specific info.
yes, yeah, you don't want to be highlighting the sentences, but if you want more information on that, go watch that
Yeah.
episode. But I think there's something that's really important when it comes to like mapping the passage, because I hear this way too often, where it's like, Mike, it takes too long. It takes me
It
too
takes
long.
too long.
It takes me so much longer. And here's my thing when it comes to time. I agree. I agree in the sense that, and say with me, it will take a little bit longer to read the passage. I am totally with you. Instead of 2 minutes, you might take 3 or 4. You're right. You're right because you wrote it. But the questions will go
Yeah.
from 2 minutes per question to like 30 seconds, 45 seconds per question. When I'm working with students, right, that's how we start. It's always the same conversation with every single student. I want you writing down the bio passage. It's going to take too long. Okay, just do it. When they do
Hmm.
it, they find that these questions go from, oh my goodness, how am I supposed to be thinking, to, oh, I have that on my scratch paper. These
Hmm.
sections, like on ChemPhys and Bio go from I barely have enough time to finish to, oh, I had like 10 minutes at the end to go check my answers.
I almost feel like, we use the analogy of a staircase, right, with taught, and I almost feel like it's the same way. Oftentimes students are like, I'm going to skip the passage. I'm just going to skip the passage. I'm just going to go straight to the questions and expect myself to do it, right? It's like, okay, I give you 7 minutes, right? You have to get to the top, the landing of this staircase. Would you like to take steps to get there? Or do you want to spend 7, 8 minutes brainstorming how you can scale a wall or just jump up there? Like, if you give yourself 0 minutes for the passage and 7, 8 minutes for the questions, it doesn't make it any easier. You don't have any knowledge. You have not walked your way to what you need to do at all. You're
Mhm.
still at the bottom of the stairs. How could you perform well, right? When you read the passage and you start to understand what might show up in those questions. You're understanding the relationships. Even if it's a question that feels unrelated to the passage, at least you understand the context, right? But oftentimes you get so many hints and so many clues. The data is valuable. Obviously the values with the units are valuable, but all of the relationships, things like this that you want to track and visualize, if you spend 10, even 10 minutes instead of 7 or 8 on those questions, you can't not, you can't succeed without having that background, right? So read the passage, right? Read the passage, try and understand those things, because when you get to the questions, you don't need 7 or 8 minutes on the questions anymore, right? Maybe you spent 4 minutes on the passage, but now these questions go by twice as fast because you've already walked your way up the stairs. You already know what's going on,
You
right?
did
The
the work,
questions,
right?
you've already done the work, right? The same way that it's hard to just look at a figure and just say, what's the trend? Like, I don't know, I have no context. Looking at a question and just trying to be able to say the answer doesn't make sense unless you have the context, right? Read the passage, do your best with the passage, and then go do the questions and have a much higher accuracy and get through them quickly, right? I love your phrase or your
Oh,
snappy little
yes.
saying, slow is smooth and smooth is fast. That you mentioned like a month ago. I think about it often.
Oh, stop.
It's so
Yeah, it's so
profound.
good.
Slow
It's
is
so
smooth and
good.
smooth is fast.
Hmm.
You do it once the right way and it goes so smoothly versus I'm going to go fast because I'm scared I don't have time. I'm going to skip the passage. I'm going to go to the questions. This question is clearly asking about something I don't know. I have to go search through the passage again. I think it means here, but I've skimmed it, so I don't really know. I'm going to guess on this question. Go to the next one. Where is
They're
this?
going back
Right? Go
and
back,
forth.
read it again.
Hmm.
It takes so much longer when we
Hmm.
skip steps, right?
Hmm.
So slow is smooth, smooth is fast. I love it.
I love it
That's
too.
why we go through
It's
things
so
like
good.
this.
It's so
It's
good.
so good.
And it's also this is also for the people who like feel that like, okay, I don't I some maybe you're not somebody who feels lost in a passage. Maybe you're somebody that's like, I can read a passage and understand it. Oh, maybe I shouldn't be writing relationships. But those are the kinds of people who always feel like, oh, I missed this detail in the passage, or I missed this thing in the passage. That's why
Mhm.
I struggled with that question. Well, no, duh. Right? Your
Yeah,
short-term working memory. Remember, when we talk about psych-soc, you can only hold, this is like Miller's Law, 7 plus minus 2 pieces of
plus or minus two.
information, right? There's probably more than 7 pieces of information in this passage. So it's not even reasonable for you to think that you can keep it all in your mind, right?
Yeah.
We're surprised. Oh my gosh, how did I miss that detail? Well, no, duh, you didn't write it down. So it
Mhm.
fell out of your brain. So
Mhm.
this is not just, it absolutely goes wonders for if you feel super overwhelmed by the passage, but if you also feel like you miss details from the passage, it's also useful. Write things down. I beg you, please.
One clarification. Same way with highlighting. Highlighting is an amazing tool, but it's not to be overused. We're not telling you to take copious notes. We're not
Yes,
telling you to make an
no. Hmm.
outline. Like
Hmm.
it's the things that with your practice you're like, "Ooh, we're talking about amino acids here. Maybe I always miss mutation questions and I realize this is S106E. Okay, you know what? I know that this is important. Maybe I'll highlight it. Maybe just to make my life easier, I'm gonna put that's serine to glutamate, right?
Yeah.
Just I'm gonna write it out, right? If it's something that you're worried you're gonna forget, or it's processing that is easier to do in the moment for you, and then if
Mhm.
you got a question, what was going on in that mutation, you just look down. If that is easier and helps your accuracy, those are the kinds of things that you want to write or
Right.
draw, right? Don't take notes. Not everything, you're not
Don't
writing
write
out
everything.
literally everything. That
Sure.
will take too long, but that's the caveat. You want the Goldilocks zone. Not too
Right.
much, not too
Yeah.
little, right? What is going to help you? Same deal with highlights, really.
And if you actually want to check out like how we do that, like you're like, I can get it conceptually. I hear in the podcast you guys are saying, come join our free trial sessions where we hold free
Mhm.
sessions every Wednesday, where we alternate between MCAT math right now, which is super awesome. It's a lot of fun. And also science passage strategy where we do just that. If you want to see how Molly and I like actually write down notes in a science passage, you can come completely free. Check it out on the Jack Weston page. It's on Wednesday nights. I might be changing the next few weeks. Molly's gonna
We'll
be doing
see.
them. Yeah, we'll see. Okay, check out the page for you to get more up-to-date information on the JW page. Molly's gonna be doing them. It's gonna be gone. I'm gonna be away for a little bit, and but yeah, if you're having trouble visualizing, highly recommend to attend. It's also a good time, so you should
Yeah,
check it out.
we have a lot of fun.
Mm-hmm.
Um, yeah, and really, I mean, I think those are the key types of passage personalities. There is one more that I want to mention because it's really cool. And I think a lot of people have heard this. We just talked about how biochem can show up in ChemPhys. It's, actually a huge chunk of ChemPhys. Bio can also show up in chemistry and physics, right? It's a pretty small percentage of questions. Again, only 5% of ChemPhys questions are on bio, but that doesn't mean the passages can't be very bio-related. And we actually see this pretty frequently because, as you know, the MCAT loves to test connections. It is very common to see a passage that's, let's say, all about the respiratory system. Huh? Right? Like
In
maybe you'll get,
ChemPhys?
yeah, I know that's bio. It is, right? But the thing is, you're studying to be a doctor. Obviously, this is very biologically focused, right? Your career will be, although you will see all of these subjects in there. But a lot of the ways that we test this information, OChem, Gen Chem, physics, etc., is through the context of biology. You need to understand how, let's say, the respiratory system applies to fluid dynamics, right? Or how fluid dynamics applies to the cardiovascular system. They will ask you to connect ChemPhys topics to bio. So you can actually see passages that are describing lung function, right? Or neuronal signaling with electrostatics, right? Or mitochondrial function with electrochemistry, right? Like it's very common to see intersectional or interdisciplinary passages, right? And of course, a lot of the questions are going to be physics and chem and biochem, et cetera. But the passage itself can be very biologically focused. I think this is nowhere more pressing than physics.
Yeah.
There are so many physics and bio connections. And this is to the point where if you are someone who tells yourself, I hate physics, I never want to study physics, physics is useless in medicine, I'm
Mm.
going to challenge you every time you study physics, every physics concept that you learn, Google, right? How does this concept apply to biology or medicine? Because not only is that actually great studying, since so often we test physics in the concept or in the context of biology, but it also will help you realize that it is critical information to have. There's a reason why this is on the MCAT. It's not just to make you miserable, right? Physics explains so much of what goes on in normal physiology, but also helps us explain what goes wrong in pathophysiology, right? It's valuable to know. But it's not something you would expect in chemistry and physics, but chemistry and physics is not just chemistry and physics. There's so much
Absolutely not.
bio, and obviously there's so much biochem as well.
Right, right. And I think this is also really, and you kind of brought it up, and I kind of want to hammer that point, is when you're studying this stuff in the first place. A lot of people kind of make, the mistake, I would say, of just reading the physics textbook, right? Let me
Yep.
just grind physics. Let me just focus on physics. Let me just do the forces, then energy, then power, and do these things. And don't really, while they're studying, connect it to the areas that it really applies to, right? We just say, oh, physics like this, then chemistry, and then bio. Where a lot of times when you and I make study schedules for students, or we are advising students in the study schedules, we recommend interspersing the content areas. Don't grind chemistry, then biology. Intersperse them together because a lot of times they go really close hand in hand. Especially there are certain topics we always love teaching together. My always go-to is like fluids and cardiovascular system. Like I can't like
Yeah.
anytime I see anything to do with blood in a ChemPhys passage, I'm like fluids questions. I already know there's gonna
Yep.
be a fluids question. Like
Yeah.
anytime there is like about a neuron in a ChemPhys passage, I'm already thinking right electrostatics. I'm thinking about maybe they can
Yeah.
even ask me about the capacitor, about about
Mhm.
myelination. I all those things are already in my mind because when I learned it. I learned them next to each other. I already knew
Yeah.
they were associated. That kind of my own neuronal connection, those two kind of nodes already connected.
Yes.
Or a lot of those people, when they're studying, those nodes aren't connected. So that when they see, a neuron, they don't immediately think of a circuit. When
Right.
in reality, it absolutely can be.
Yeah. And I feel like this is why it's so important whenever you're learning content within any section, but especially chemistry and physics. Don't just use your chem textbook from college,
Mhm.
right? Like there is so much to be said for if you like learning from books, learn from an MCAT book, not
Mhm.
an undergrad book, because MCAT books are filled with connections. That's the whole point, right? And if you already have a book series, cool, use it, right? We actually have free textbooks on our website if you want
Totally
them.
free.
They're pretty awesome. But the whole point is an MCAT book, regardless of where you find it, the whole point is to prepare you for this test that makes connections. An MCAT physics book is going to give you a lot more connections to bio and biochem and OChem and gen chem than a physics book from undergrad, right? It doesn't care to make any of those connections because that's not part of the curriculum, right? So just something to keep in mind if you are someone who likes learning from textbooks, or even let's say we have students that are out there that are like, I don't need to do any content review because I'm a junior in college and I've already taken all those courses last year, super fresh on my mind. I don't need any content review. It's still useful. You do still have some content to learn, and it's specifically the connections, right? That is going to be a really important aspect of achieving a high score, being primed for those connections. So something that pretty much no matter how strong our content background is, that is not really something that is tested or, even part of a curriculum until you start specifically studying for the MCAT. So something worth keeping in mind. And in the realm, I know you brought this up as like a common kind of mistake that students make, or things that we feel misguided about, right? Of, trying to just study each subject individually. Of course, we want to make connections, but there are a lot. And I think more so in ChemPhys than maybe any other section. There are a lot of things that we do and maybe don't recognize are not the most optimal way to do it, right? And I feel like this is very pressing in physics. We've talked about this before with MCAT math, but when most people think physics for the MCAT, they think, cool, I memorize an equation sheet and I'm done,
My heart
right?
just like broke a little bit. Like
I
like an
know.
angel just yeah. I'm like, oh.
An angel lost its wings.
Yeah.
It's everywhere, right? Go on our MCAT, this information is shared constantly, right? Oh, you just memorize an equation sheet, call it a day. As we've talked about, that's not useful. Go back, listen to MCAT math if you want. But again, how do I know what V means in PV equals nRT? Is that velocity? Is that voltage? Is that volume?
I don't know.
I,
There's so many
I
V's.
don't, I have no idea, right? Like you need to know, sure, the equation, but you have to know what the actual variables are, right? What does V mean in this particular equation? What are the units, right? Keep in mind, they're not going to tell you in every passage, oh, the voltage was equal to 9 volts. The, electrostatic force was equal to 1 Newton. They don't owe you that, right? They could give you 9 volts and you need to know that that's voltage, and you need to know that that's V, and you need to know every equation that has a V in it that is specifically voltage, right? You should not be thinking of PV equals nRT for a voltage question. So do you need to know equations in physics? Of course you do, of course, but just memorizing an equation sheet is not enough, right? We do need to go deeper with that. And this is something that really impacts the questions as well, not just the passages.
Yeah, and I think with equations, like I always use like I ask a bunch of questions to students, be like, hey, do you know if you're memorizing equations? They're like, I think I am, I don't think I am. Well, let's see. Right, the kind of common question that I ask is, hey, do you ever do a math problem and you're like super overwhelmed and you don't know which equation to use, but when you looked at the solution, oh, it
It
was
was,
so obvious. It was just such an
yeah,
easy
silly
equation. Silly
mistake.
mistake. Oops, absolutely not. That
Yeah.
usually means you're memorizing the equation. Or you knew which equation to use, but you didn't know how to use it. This is really common with like something like the Bernoulli equation, for example. Like that's a very common one where people look at that equation and they're like, what is this beast of an equation?
How
But
do I use
because
it?
how do I even use it, right? Because they don't understand it. They just memorize the sheet. Or a common one, and this is I'm going to shut up Miles down because this is a common like the Nernst equation. I can't tell you how many people have looked at the Nernst equation card. You cannot tell me at all what that equation means. Like how do you actually use it?
Mhm.
Because you know the card I'm talking about, right? Like that
Oh
Nernst
yeah,
equation.
I know.
Yeah.
Yes.
And they're like, yeah, I memorized the Nernst equation. I'm like, well, when are you supposed to
Know
use
what it
something like
is?
that? And they're like, I don't know. Right? It's like stuff like that where it's like it's not useful to just memorize them because you need to know how to use like they're tools. You need to know how to use them.
Right. Yeah. And it's so, so important. And we've talked about this a lot in MCAT math. Like even another common thing with equations is jumping straight to the math, right? Maybe you don't need the math. Maybe just a solid understanding of the equation and the relationships between variables. Sometimes that's enough. The important take home here with physics and math, which of course is very related to chemistry and physics as a whole, is please, if you struggle with a physics question that's calculation based, let's say you did a full length, you saw that you got this question wrong, do not look at the solution right away.
Mhm.
Rework it and see at what point do I run into problems, right? Because there, you could miss a question. Let's say it's a physics calculation question. maybe we didn't even know what the units were that we were given. So we didn't know any of the variables. We had no idea what the equation is. And of course, you can't get the math right if you don't know what you're solving for. That's a very early issue, right? Okay, go to the solution, get a clue. Oh, okay, this is voltage. Ah, okay. Now I kind of know. Now I know the equations I could use. Keep working, right? Give yourself little bite-sized hints because you could, another hypothetical, same question. Maybe you understood all the values with units in the passage. Maybe you could identify what variables they were. You knew the equation, and maybe you started with the math, you got all the way through, but you dropped a kilo, right? Like it
Mm.
was kilograms and you thought it was grams. You know, like maybe it was one, not a silly mistake, but
Mm.
one simple issue with your math, right? In which case, like if you had been a little more careful, you would have gotten it right. That is very different, right? But both of those students are going to look at the solution and be like, oh yeah, duh. You
And
don't
gain nothing, and then gain
They
nothing
gain
from it.
nothing, right? So like, please rework the question. If you know you missed it or you know you struggled with it, rework the question and see at what point do I need help? Okay, because those are two very different student situations, and yet they will look at the solution and say the exact same thing. And neither of them is going to learn from that mistake, right? So take it from us, right? We need to learn our equations the right way, of course, but then also don't just look at the solution if you realize you got something wrong or you thought something was hard. Make sure to put in the work, or else specifically, right, for those calculations, you will never improve. And
Hmm.
that's, the
That's
only
so
true mistake
frustrating,
is
right?
the one you don't learn from,
Hmm.
right?
Hmm.
You got to figure out what's going wrong so that you can fix it. If you just say, "Oh, I'll get it next time," you won't,
You
right?
won't because you didn't change
You
anything, right?
won't, right?
Yeah.
Yeah.
And that's like one that probably the equation one is one that I think one of the most common ones. But there are other mistakes, but some, well, those that we've already and struggles that we've actually already touched on when we are talking about the different passage
Mhm.
types. And I'll kind of going over them
Mhm.
quickly, like things like ignoring the passage and ignoring the
Mhm.
figures and going straight
Ignoring
to
the
the question.
figures.
I'm
Yep.
not gonna beat a dead horse with a stick at this point. Like
Yeah.
we anyone listening to this, if there's any ambiguity about where we stand on that ignoring passage,
Yeah.
I'm going to say that we do not ignore the passage. We do not skip the passage. We don't skip the data. We read it.
Mhm.
We read it thoroughly. We go slow. We go smooth, and that will actually
Slow is
prepare
smooth
us,
and smooth is
right,
fast.
for the question. I know, isn't it so good?
It's so
Um,
good.
and so another one, which again we talked about when we talked about data interpretation, units. Pay attention
Mhm.
to your units when they come up.
Yeah.
Don't just
Mhm.
assume you're going to pick up on the units. Oh, I'll pick up on it. Just trust yourself. No, that's how we miss things, right? Actually
Mhm.
structuralize it, formalize your approach to pay attention whenever there are units, whether it's in the passage, it's one of your things that you highlight, numbers with units and buzzwords are the two, or it's in your data where, okay, it's part of that TAU to pay attention to the units. Notice in our strategy, looking at units is part of the plan. It's formalized. Don't just assume you're just going to luck out and you're just going to, oh, I'll pick it up when I read it, because that's how we miss things.
Mhm. Yeah.
So making sure you're actually paying attention to units, because those again low hanging fruit there. Those are easy. Those are again quote unquote easy points that we can be making.
Mhm. Yeah.
Um, and again, finally, and I think this is related back to ignoring the passage and the data, where when you go to the questions, you treat them like content questions. So many people look at like questions associated with a passage and think, oh, I can just solve this with my content, especially when they didn't even read the passage in the first place, right?
Yeah.
A lot of the times you're going to read a passage, or let's say you did read the passage and then you get to this question, and you found that the passage and your content are at odds with one another. And you think, well, my
Mhm.
content says this one thing, so that's what I'm going to use. No, there's this rule that we always use. The passage always takes precedent. It will happen, and I can promise you it will happen, where the passage is going to say something that is contradictory to your content. It's actually like, it's not common, but it's also not like
It's like a
unheard
trope.
of. Yeah,
They
it's
do
kind of
it.
like a
Yeah.
trope. It's not like every passage, but like it happens,
They
right? They
want to
want to
see
make,
if you're paying attention.
right? If they do that, the passage takes precedent. I don't care if your content says resistors don't change, like resistors aren't variable, right? If the passage says the resistor is variable, it's variable. End of story. That sort of deal. Where your passage always takes precedence. So these questions will sometimes test on these changes that they made. Well, therefore, you must have read the passage. You can't just treat it as, oh, that's what my content says, so let me use that way, right?
Yeah.
So do not treat all these questions that are associated with passages if it's just from your content. You need the passage. The passage is always number one.
Yeah,
Mhm.
absolutely. And I feel like when we're talking about questions, as we've mentioned before, we had a video where we went through all the most important things to keep in mind with MCAT questions. And a lot of this comes from that, right?
Mhm.
It's not unique to chemistry and physics. The idea that we need to read the passage first and passage takes precedent, like none of this stuff is brand new. If you've listened to a lot of our episodes, again, I hope there's no ambiguity on where we stand with that. But I think it's valuable to look at our general approach to questions and talk about what specifically is going on in chemistry and physics,
Mhm.
because we do have some specific differences between a question that belongs in ChemPhys versus biochem versus psych-soc, right? So to walk through the strategy from a bird's eye, right, from a very zoomed out perspective, when we approach a question, again, we've already read the passage, we've already got the basic idea of what's going on. The first thing we're going to do, shocker, is read the question, right? You need to know what the question is asking you, but we don't stop there. It's not enough just to read, right? You need to start thinking now, right? Kind of the same way that we don't just expect ourselves to be able to look at a figure and tell you the trends, that you have to put in the work first. Don't just expect to skim the question and then immediately be able to pick the right answer. That's not how that works, right? We have to process the question before continuing on. You have to figure out, what am I looking for, right? Oftentimes, and we use this phrase a lot, the rephrase. You read the question and then you rephrase the question. I find that sometimes students are like, cool, shuffle the words. This is now a
Mhm.
rephrased question and I'm done. No, no. What is the question asking you to do? Right? Start to think, is this information going to come from my content knowledge? Is there anything in the passage that's relevant to this? And again, if there is stuff relevant from the passage, that is what you use. Even if it's contradictory, I don't care. Passage comes first. So read the question, does this remind me of anything from the passage? Right? Is it asking me about power, and I know that I was given something with joules, a work value, right? Like, oh, okay. Before I just look to the answers or before I start doing calculations, as I'm reading that question, oh, okay, they're giving me power. I know powers work over time. I knew I had work. All right, are you going to give me time so I could calculate power, right? Like, this is a very active process when you read, and you want to be starting that understanding process while still reading the question before looking at your answers. Because if you don't know what you're looking for in the answers, you're going to fall for every trap they set for you.
Mhm.
They will give you questions, or they will give you answers that sound right, but they're actually wrong. They'll give you questions or answers that are true of part of the passage, but not true of the specific part of the passage that they're asking you about, right? You have to be intentional when you read. And please don't jump ahead and look at the answers before you truly understand the question, right? Again, slow is smooth and smooth is fast, right? Goes through one step at a time. You are walking your way up the staircase to get to that correct answer instead of imagining doing a mega high jump and expecting to just, of course, B, right? You can't do that. And you also need, when you know what you're looking for, you're looking at the answers, you need to be systematic, okay? I have two answers that both look okay based on the passage. Refresh yourself on the question. What am I supposed to be answering here? Right? Only one of these can be the correct answer, right? One of these is wrong, to put it differently. So which one is wrong and why? Right? Why is B worse than A? Why? You need to be intentional, right? So we should be thinking when we read the question, can I anticipate anything about what I'm going to see in the answers? And we need to be really careful when we evaluate and ultimately eliminate our answer options, right? Again, this is general, but we see it applied to chemistry and physics all the time, right? We need to be careful about what the context is of the passage and therefore what equations we might be thinking of, what types of questions we've seen asked about this in the past, etc., so that we can apply this intentionally for this particular section.
And I'm you're it's so cool like to think about like how we're applying these things that we talked about with the question strategy specifically to ChemPhys. And I think
Mhm.
this idea of the thinking before you look at the answer options, because I think you said that, and I kind of want to hammer it, where you said the thinking starts in the question. Yeah, I see so often students like read the question and then just like, okay, cool,
Oh.
and then only look at the answer options. And then when they look at the answer options, that's when the brain actually starts turning. That's when the gears actually start when they look at the answer options. But then they didn't even know what they're at like answering. So they're like, oh my goodness, I'm overwhelmed already. I don't even what I see these numbers, like what am I supposed to use? Which equation am I supposed to go to already? Right? Where the thinking needs to start in the question, to rephrase, to anticipate. Then when you look at the answer options. And of course, the strategy kind of really deviates whether this is a math question or maybe not a math question, maybe this is a data interpretation question. There's these
Mhm.
different types of question, but the core is the same. What's your base? Where are you going? Is this in the passage? Is this in your content? Go back to that thing then. Read that thing.
Yeah.
Oh, and I think this is something maybe we haven't mentioned. I know we mentioned in the science passage strategy, but I'll remind you again, don't feel like you have to memorize everything in the ChemPhys passage. For these questions, go back. If it's something from data interpretation, don't feel like again, this might seem like very like tongue-in-cheek like advice, but like I see so many students that are like, oh, I remember that from the passage.
Just verify.
Just go double
Just
check
make
it, right?
sure.
Like let me use my memory. And again, I don't say that from a point of, oh, how dare they? I would do this all the time where I'm like, oh, I remember that from the passage, so I'll answer the question based on my memory. When it was right there. It was like this avoidable thing, even though it was right there. Do not rely on your memory for the sciences. Please don't. You can always, this is very different from CAR's strategy, where CAR's you never go back to the passage for a very good reason. And if you want to talk about cars, we have the other podcast. Molly and Jack do a great job. But for the sciences, you always go back to the data, go back to where they send the passage, and just refresh your mind right before you
Yeah.
actually look at the answer options.
Yeah. And I feel like what you're saying is so important. And it's kind of making me think about, right, why we have to focus on the question first, right? It makes me think like when you jump straight to the answers before understanding the question, you now have four opportunities of it's one of these four, and you are almost taking these answers and trying to twist the question to fit.
Mm,
You've read the answers, you understand the answers, and now you're looking at the question and you're like, well, if I twist the question this way, this is the answer. If I twist the question this way, this is the answer. You are going to adjust your understanding of the question to fit one of the four answers, whichever one your brain likes the most, versus you process the question and you realize, oh, this is what the question means with no context of what you're going to see in the answers. And then when you go to the answer choices, you're like, oh, this one fits my reasoning. That's it. Right? That's why we don't jump around, right?
mhm.
That's why we slowly process and we move through our way in a or our move through our exam in a systematic way, right? You always process the question before you move on.
Mhm.
Um, and I feel like it's valuable. I know we're talking about ChemPhys. I know that there's so many different layers to a ChemPhys passage. And we're telling you, feel free to go back, right? Feel free to go back, right? Once you understand the question, you can do anything you want. I feel like it'd be nice to go through like a very hypothetical example,
Sure.
right? How can I tell if something is content based? How can I tell if something is related to the passage? Where do I go? Right? So let me give you a hypothetical, Mike, right? Let's say that
I'm
we're
there.
opening up. You're like, I'm sat, I'm good. Let's say that, you've started a full length. This is the first passage that you see. And I'm
Okay.
not saying every passage is like this, but
Mhm.
let's just give a
Mhm.
hypothetical, right?
Mhm.
Let's say that you have a passage that
Mhm.
begins with, let's say it's chemistry. It's background info on a chemical reaction, right? So this
Cool.
reacts with this as a reagent, blah, blah, blah.
Have
Let's
they given me
say
figures or not yet? I don't know yet.
let's say they
Oh,
do. Let's say you get
sure.
a paragraph. And
Hmm.
actually, you know what? I feel like this is funny to mention because I've seen this multiple times in ChemPhys. Sometimes they'll give you a really dense paragraph where it's describing a reaction, like
Hmm.
every step. Step one is this and this and this, and step two is this and this in the paragraph. And if you just look just below it, there's a visual.
There's of the
Like
exact
this has
they do
happened.
that very commonly. Like this is
It's
not
so
like an
common.
uncommon thing. Yeah.
Like, and in that case, just as a note while we're walking through the passage, if you start to feel like there's this multi-step reaction and they're giving you like reaction one or step one involves these intermediates and they're doing this, and then step two happens, look below it. If there's a
Yeah.
visual for it, all you're doing while you read is, oh, that's what's happening
Follow
at that.
along.
I
Yeah.
see this intermediate, I see that one.
Mhm.
Cool, I get it now.
Mhm.
Like you're using the map as or the reaction
Mhm.
as a tool to help you understand the passage.
Right. Right.
Okay, so
If they
let's
don't, But if
Yeah,
they
if they
don't,
don't, you
write it
could map
out.
it.
Yeah,
Yeah.
that's why I asked,
Yeah.
because I'm like, okay, am I mapping this? Am I not mapping this? I need to
Okay.
know if there's a figure. Yeah.
Fair, fair, fair,
Yeah.
fair. Okay, so let's say they gave us a situation like that.
Sure.
Big, chunky paragraph
Love
one,
that. Love
right?
that.
With all of this detail, but they do give you a nice reaction. Let's say
Yeah.
it's pretty extended. Let's say that there's
Mm,
like 6 intermediates, so 5 steps.
cool.
Kind of long, right? But you have visuals of
Hmm.
the different structures of the intermediates, and you've got numbered steps. And
Hmm.
then, of course, the paragraph up above gives a lot of
Sure.
detail.
Yeah.
And let's say we're going to do an experiment based on this.
Mm,
So you now have another paragraph that has a research setup. They're going to give you, the actual material setup for whatever it is, whatever
mm,
chemical reaction we're doing. They've got values with units for concentrations,
mhm.
things like that. And then we get a research figure. Okay,
Got it.
that's your
Got it.
passage.
Cool.
That's your passage.
Cool.
Now,
Hmm.
first of all, let's just be general. What kind of questions might we get on a passage like that?
Oh
We've
my
got chemical
goodness.
reactions, we've got
Yeah.
paragraphs, we've got two different types of figures, a
Right. Right.
pathway and a research figure, and we've got methodology.
Hmm.
What are we going to
I
see?
there's so many
Lots. Yeah, there's
lots of
so many
questions.
options.
But there's like a lot of options here, but I'm already visualizing like I because I feel like I've seen this passage a million times, right? This is kind of like an orgo passage with a little bit of like chemistry
Gen
there with
Chem,
like Gen Chem.
yeah.
So I already know I'm probably going to be seeing something about like maybe something about redox reactions because there's maybe a redox
Mhm,
reaction going on. I'm being asked
mhm,
if we switched out a reagent for something else, what would it be
mhm,
instead? Right? I'm going to be asked things like about data interpretation, but on the graph, what was the trend?
mhm.
Maybe it was asking about an enzyme, one of the specific enzymes. We made a modification. Oh, what? We'll look at the trend after. Or maybe we added this molecule to step. This is the enzyme for step number 4. Now we added this molecule. Now look at this trend now. I'm now being asked about inhibitors. I'm going to be asked maybe about calculations. Maybe it's a stoichiometry. Maybe it was 2 parts, one molecule that combined for one. Okay, now it's a stoichiometry question. I'm thinking there's all these questions they could be asking me about calculations, about data, but I'm already thinking I already know what they're going to ask. It's just
Yeah.
which one are they going to do? Like it's never going to be a surprise. Maybe they're going to be asking what's the most likely mechanism, or I'm not going to be able to anticipate that answer, but I'll be able to eliminate through it, right? I'll
Yeah.
know what it isn't, right? So
Yeah.
these are the sorts of things that like I'm already thinking that could be in my questions based on everything we've got so far.
Which is totally fair. There's so many options. Let's say, as a hypothetical in this scenario, let's say they give you a calculation question. And
Sure.
let's say all you know is that it's a calculation question. Let's say you don't get any other hints from the question, which of
You
course you
say
would.
this is a calculation question.
Calculation question
Yes.
from the setup I gave you,
Mm,
where are you looking? Again, we've
mm,
got background info, we've got a research or a reaction figure,
mm,
right? We've got the methodology paragraph with
mm.
the research design, and then we've got a figure.
So I'm,
Calculation.
if it's a calculation question, I'm probably thinking that this is probably to do with like this setup of the reaction. Maybe they're like, oh, what was the concentration that we used? Or
Mhm.
say we've got this situation, what would it be in this case? Or maybe this was a Michaelis-Menten plot, find V naught given this substrate
Mhm.
concentration. So I'm going to be looking at that place after the figure, before the data, where they've given me the methodology, because they're probably going to be giving me a lot of numbers, lots of units. That's where we're going to
Mhm.
go. Maybe I might need to go to paragraph 1, where maybe they gave me some numbers there, but probably paragraph 8, where they gave me that methodology of the experiment.
For sure, right?
Yeah.
And again, it's probably going to be, in this example, it's probably going to be where you have numbers,
Yeah.
right?
Yeah.
That's a pretty simple way to phrase it, but
Mhm.
you know where you're looking, right? Because you
Mhm.
know what is possible to calculate. What if it was about, let's say it was about a chemical property of an intermediate?
Mm.
Where would you
Mm.
want to go for that?
Well, I'd probably look where my intermediates are. So probably into the figure, like where I have my intermediates. So maybe they're going to name a specific intermediate. So I'm going to be really looking at functional groups because they're looking about chemical properties. They might be
Mhm.
thinking about, oh, which can we oxidize, which would we reduce? I'd be looking for like alcohols, carbonyls,
Mhm.
carboxylic acids. Maybe they're talking about acids and bases. Now I'm looking for, okay, maybe some acidic parts. Maybe I'm looking for nucleophile
Fair.
electrophile,
Yeah.
right? Like I'm maybe thinking about like, okay, so where is a good electrophile? Where might they be attacking? I'd be looking at the structures in that where they show me the figure.
Yeah, even if it's like, is this going to be able to pass through a membrane? Look, is it nonpolar or is it polar? Like what the structure is going to be where you understand the properties, right? So
Hmm.
go wherever that is. What if, and I know you brought this up as like a hypothetical question. Let's say we didn't talk about enzymes at all. It
Sure.
was just this intermediate becomes this one. It's this type of reaction. Let's say it was a question where it was like, okay, this is the name of this enzyme,
Mm,
right, that catalyzes this reaction step. And then it asks a question about the enzyme itself. Most students are
mm,
going to say, oh, that's basically a discrete question. I can
mhm.
answer that without it because you're telling me something new and then ask me a question about the new info. Like, yay, I don't even have to worry about the passage.
Right.
Is there anything in that case that you would still want to brush up on from the
Mhm.
passage?
Yeah, 100%. And this is kind of the thing with a lot of discrete questions. Even though we call them like pseudo discrete questions, this is the name people say, like pseudo discrete question from like a question, all of them are related in the passage in some way. So if they've
Mhm.
given me the name of the enzyme, like the name of the enzyme usually tells you a lot about what the enzyme does. I
Yeah.
probably want to look at the step that's associated with in my figure. Like if it's associated with a
Yeah.
specific step in the figure, like, oh, it's like a dehydrogenase. And I know there's a redox reaction, that's step number 3. I'd probably
Yeah.
go look at that step to be like, okay, wait, what exactly changed? And probably because paragraph 1 was like the actual explanation of the figure, I'd probably also look at paragraph 1, that background explaining it to kind of look at, hey, were there any numbers there? Because I don't know what kind of enzyme question they're asking me now, but maybe there was a specific amino acid, something along those lines. That's where I look at 1 and 2. Even though it's pseudo discrete, I'd still brush up because there's a lot of times where there might be a key piece of information that I would miss if I just thought, oh, this is just a discrete question. So even though
Yeah.
it might be a like a big content piece, I would still go back to that associated area of the passage just to like again get that piece again.
Yeah, and you have the confidence of like, okay, I just went back and I refreshed. Now I have the confidence and the context to answer the question. And if you don't need it, like sometimes, they give you something to anchor. I
Hmm.
always think of a question that's in one of the section banks where they literally all they did was mention the word liver. It was not a big
Mm.
part of the passage. The only context was the word liver. That was it. The question's asking which of the following is a function of the organ mentioned in the passage. Like, okay, once you know that it's liver, that was not a key point of this passage. Once you know it, that's it, right? But
Right.
it's still good to refresh and make sure there's not multiple, right? It gives you confidence of like, okay, I scanned, there's only one organ, it has to be this. Now it's content, but there's no oops, I didn't notice, I didn't see this, I didn't realize that this was actually liver tissue from a different animal or like it doesn't just make sure, right? Because you
Hmm.
don't want to feel like you've got tense myself to say this, a
Oh,
silly mistake.
I know, no, yeah, we're like, oh no, I missed that thing when I skimmed
I
through the
know.
passage in a minute and a half. Like, no, it's
Mhm.
like maybe if you just
Just
actually
make
read it.
sure it gives you
Yeah.
confidence, and
Mhm.
oftentimes it'll give you something that's really critical for that question, actually.
Sure.
Even if you think it doesn't matter, sometimes it does.
Mhm.
Um, and okay, so I feel like we've gone through so much advice with ChemPhys.
Mhm.
All of our listeners are ready to go out and tackle some practice questions.
Mhm.
But let's say that we're earlier on, right? I
Yeah.
feel like we should just take a sec. Let's just rapid fire, right? Like, what are the things if someone has, let's assume let's assume one of our listeners somewhere has completed their undergraduate degree. They've taken all
Yeah.
these classes, right? Maybe it's been a year or two. They need to brush up, but they're like, I've taken them all. I had equivalent grades in all of them. Where do I start? What kind of topics do I prioritize? Right. Of course, you know that Gen Chem is technically the highest yield,
Mhm.
right? And then physics and biochem and orgo from there. And you even get a tiny bit of bio. Um, but let's talk, like, let's say physics, rapid fire, right?
Mhm.
Uh, I would say work, forces, work, or energy and power are pretty good. That's the last episode that we did. That's pretty foundational to
Mhm.
everything.
Mhm.
We could talk about fluids, we could talk about circuits, we could talk about waves and light,
And
right?
optics,
Sound
right?
too, especially how sound and light are different.
Mhm.
I feel like those are the most important. From there, you can get into things like electrostatics and magnetism and other topics, but like those I feel like are pretty critical. Those would
Yeah.
be my couple that I pull out from physics is like, make sure you know those.
Make sure you know though. Yeah, I think
Yeah.
yeah, I would say like especially and this is kind of a sleeper pick, but optics. I think optics is one of
Optics.
those is one of
Mhm.
those areas that I think gets overlooked a lot. That I think
Yeah.
is really can't because it has so much application, especially when it comes to eyes. Like if I
Eyes.
see
Yep.
anything to do with eyes in a campus fashion, I'm like
Mhm.
they're gonna ask me an optics question.
Yep.
So that's
Oh,
why
for
I'm
sure.
oh 1000%. So that's
People
why I'm
bundle
like
it in. people bundle it in with light, but then light becomes this absolute monster. It's a separate
Massive
topic.
thing.
Okay.
Yeah, like
Separate topic.
because optics has to do with like mirrors, lenses, but then there's like a Snell's law, but there's also all these things. So
Yeah.
like
Indices of
yeah.
refraction and
Yeah,
yeah.
it's yeah. So that's why I kind of like light is one thing. Sure, it's related. Of course, is related to optics, but I kind of say it is kind of its own thing. But no, absolutely, I would agree. Physics, those are the main things. Yes, there are other things like electrostatics, magnetism, something that people really fear a lot. There's not that much magnetism.
Actually, so
It's just so a narrow amount of magnetism.
I love magnetism. We should do that for a content episode at some
I would
point
love
because
to.
there are literally only two types of magnetism questions on the MCAT, and it's so fun because it's so much easier than you think it is.
Right. And it's actually
Like that
accurate
is
too.
one
Like
topic I love.
I'm like doing this, I'm like doing this, I'm like
The right hand rules
my
and
right hand rule. Yeah.
easier than you
It's
think, promise.
it's very like there's even though that's like a bit like oh my gosh magnetism it's a really small part
Yeah.
like there's not many ways they can ask those kinds of questions but that's why it's like okay while it's good it's testable it's not like if you're going to be learning
Mhm.
physics like we talked about before forces and
Medium yield.
energy fluids yeah that's like
Those are
medium
high
yield
yield. Yeah.
right in Gen Chem like this is where there's like huge and we've actually covered all of these things in previous podcast
Mhm.
episodes so like acids and bases. Oh my goodness, that's huge. Like
Huge.
acids and bases, like because there's just so many applications of it. Like you need to know
Mhm.
your acids and bases well, not just memorize
Yeah.
what the strong and weak bases or acids and bases are. No, well.
Mhm.
Equilibrium. Oh
Yeah.
my goodness,
Also
ideas of like
huge.
like
Mhm.
capital K, the equilibrium constant. Because again, like
Mhm.
it's related to homeostasis. It's related to the ideas of every single reaction. Legitimately,
Yeah.
every reaction
Yeah.
it's related to.
Mhm.
Electrochemistry. Electrochemistry is great because it not only has biology connections, but in terms of like batteries. Electrochem is also important for redox reactions, so metabolism. Like these things like are because it's so big and because there's so many biology applications to them, they love
Mhm.
testing on electrochem.
Yeah.
As well as kinetics, right? Kinetics very closely related to enzymes, so that's why
Mhm.
kinetics, knowing it very well, the ideas of kinetics, how completely devoid and unrelated it is to equilibrium, right? Like
Yeah.
kinetics and thermodynamics, how very different they are.
Yeah.
So those are like Gen Chem topics that are like you should be very comfortable with these.
Yeah. The only thing that I would add with Gen Chem is just make sure. I know no one likes, oh, periodic table trends, blah, blah. I honestly feel like before you make your way into OChem and biochem and even the rest of the topics within Gen Chem, just making sure you understand what an atom is and
Mm,
how to understand the properties of an atom. Does it want to gain an electron? Does it want to lose an electron? Like, what does it mean to be this particular element? What does the bond look like? I feel like
mm,
when you start to layer in biochem and orgo or ochem, and you start talking about, even things like acids and bases, right? Or electrochem, it's all built on a understanding, which a lot of us are comfortable with this already, but an understanding of how atoms behave. And I feel like when we talk about, breaking bonds or forming new bonds or transferring a, functional group from one to the next, it's all built off these fundamental properties, but I would I wouldn't say it's the highest yield to be tested directly, but I feel like it's so foundational to talk about things like atoms and bonding that if you're like, oh, I want to start from scratch in Gen Chem, make sure just to look at it, right? You might
Starting at the
not be
periodic
doing
table
a
in
ton
great
of,
place.
yeah, may not be a ton of like new learning, but it's a great refresher before you make your way into the really high yield topics.
Yeah.
So again, not necessarily the most questions as an individual topic, but it's so foundational that it's a great
Mm.
jumping off point if you want to get more into Gen Chem or biochem. Because
Really,
again,
it's connected to
biochem is
both.
is on biochem and ChemPhys.
Right.
That I think
And
we
I think
know.
there's an important point there with the periodic trends that I kind of want to really hit on. I
Mhm.
noticed so many people memorize the periodic trends, like the
Yeah,
size trend
you
or
have to.
like the electrochemistry. In order to really get the value that Molly's talking about, because she's so correct. Like when it comes to like, it's so foundational. It truly is the stability, the acid basis to orgo, right? To actually get the value of that atomic, like the periodic table, you need to understand why the trends are the way they are. Why is it that size gets smaller from left to right? Everyone knows why it gets bigger from top down, but not a lot of
Mhm.
people know why it goes smaller from left to right. Like we just know
Top.
the trend, but the why behind it. So when you're studying these things, you have to be very, here's the word, intentional,
Intentional.
right? Where we can't be just memorizing it. Aim to understand why it is, so that for when they throw curveballs, which they will, when they throw curveballs at you in these questions, you know how to answer them. And it's not like, oh, that's not in the things that I memorized. So sorry, I just
Yeah.
had to add that because I think that's just one area that people, I think, memorize way, way too much.
Yeah, I agree. And again, the whole point is to have it be foundational to other stuff. But if you just memorize, it's not foundational because you don't understand it yet. So
Mhm.
yes, very worth it. When it comes to biochem, we know that, everyone knows you need to understand biology. Everyone knows that you need to understand psychology. You need to know how to do a CARS passage. But biochem, I feel like people think is less of a big deal than it is. Right? Like it's very relevant. It's very relevant. I think it's probably for most people the most understudied for its value, right?
Mhm.
A lot of students are scared of physics, they're scared of OChem. Those are scarier, but they're also lower yield, right? Like biochem is very high yield, and I think it's close enough to bio that a lot of people are like, "Oh, biochem's easy." No, it's not. It can be very complicated. I think it is very high yield, and it also it there's a lot to know about it. Okay, so in the context of biochem, I mean, there are so many. If we start small and build up, I mean, you need to know amino acids. You need to, right? I think understanding properties of other biomolecules is useful, but amino acids specifically and how it relates to protein structure, protein function, and enzymes, right? You need to understand what an enzyme is, what it does, and how fast it can move. You need to understand inhibition, things like that. All of this builds into actual reactions that happen in the body. Metabolism is huge. We
Mhm.
actually did a whole series on metabolism,
Whole
and that
series, yeah.
of all the episodes we've done, those are some of my favorites, especially the last one, the connections in metabolism.
Mhm.
The last one's not as useful if you don't listen to the other two or
Sure.
I think it was three. Was it three episodes? I
I
think we did
actually have a
three.
list. I think we had glycolysis, we did the PDC and TCA in one, and then we did the electron transport chain in one, and oxidase
Oh,
phosphorylation.
yep.
And then the fourth one was the metabolic
So four
connections.
episode
Yeah,
series. Yeah,
and honestly, whenever I
pretty
ask students,
awesome.
they're like they love that metabolism series. Like they just love
Me
because again,
too.
we I know it was so much fun actually doing like
Yeah.
talking about it because we
Mhm.
broke it down. Like we really
Yeah.
broke it down what you really need to know.
But it's
Like to
so high yield.
so high yield and also like on on the point of things that we see students memorize where they really shouldn't be memorizing, that's a
Mhm.
great example. Where like, oh, let me
Mhm.
just memorize all the steps instead of understanding what happens at the steps, right? To understand
Mhm.
because they're a lot of times they're just going to change something. They're just going to, oh, this enzyme doesn't work now. What happens if you just memorize the
Mhm.
list? You have no idea.
Yeah.
So
Yeah.
this is one thing where I totally agree. Something that I think is kind of underestimated, but when people do study it, need to adjust how they study it. Absolutely.
Yeah. And
Mm.
that leaves us with OChem. And it's so funny because in my head, I've worked with so many students that are the opposite. They spend too much time trying to like understand perfectly OChem. We're actually, OChem is a very interesting thing to talk about. It's actually going to be the topic of our next episode.
Surprise!
Surprise! Because OChem, I honestly think people go so
Mm,
in depth
into
because
the
it's
weeds.
scary.
Hmm.
They go into the weeds. They're memorizing the steps of like the aldol condensations, which actually that's a decent, like
Pretty
you
good.
may see that.
But
But
again,
like the
the
Michael
reaction,
addition and all of
yeah.
these other reactions, like, oh, I need to memorize this scary thing that intimidated me in OChem. It's probably not going to be there, right?
Hmm.
Most of OChem boils down to functional groups,
Hmm.
right? Functional groups. That's barely. I
That's
wouldn't
a
even think of
huge
that as
part.
OChem. Also, a lot of analytic and separation techniques fall under the umbrella category of OChem. Okay, that is not that bad, right? Functional groups, analytic and separation techniques, and then I would say a general idea of reactions, understanding nucleophiles, electrophiles, understanding basic redox reactions. I would also say understanding the reactions that each common functional group can go through. So
Mm.
like carboxylic acids, for example, right? Like in carboxylic acid derivatives, that is a pretty important thing within OChem. Do you need to memorize the arrow pushing for every reaction that's physically
I
possible
mean,
for a carboxylic acid? No, but
they're all really the same, to be honest. They're all the
yeah,
exact same. But
yeah.
yeah, no, but don't like try
But
to understand the
basic.
variations. Like they're all essentially the same, but don't try to be like, oh, is the acyl halide is like this, and then while
Mhm.
the anhydride is like this. Like, no, don't please don't do that.
Yeah, look for what is similar between reactions that have similar functional groups, right? Like you're literally just trying to understand what are the basic capacities of a molecule like this. That's it.
Mm-hmm.
Don't do more than that. You're doing too much, okay? Again, I've spoiled it early.
Mm-hmm.
Next episode we're going to walk through OChem, right? Or
Mm-hmm.
Orga, whatever you choose to say about it. This is we want you to be intentional with the way that you study, and we want you studying the things that are most likely to show up and not wasting your time on really complex material that is not really even testable, right? So that's going to be our topic for next time. I'm excited about that one, not because OChem makes me want to jump up and down. I love OChem for the MCAT because it's so fun to be able to tell students, you let me hold your hand.
You're
You
doing too
don't need
much.
it.
You're
You're
doing
doing
too
too much,
you're
right?
doing too much. It's one of those
Reel it
things where
back.
there's a core stuff you need to know, but like there's
Yes.
so much extra stuff that hey, in OChem in undergrad, yes, you needed to know that stuff.
Mhm.
Now for the MCAT, it's kind of like how the depth of MCAT goes on like immunology. It's like I see it the
Mhm.
same thing as OChem. Like there is so much depth.
Yeah.
But the MCAT just scratches the surface. Yeah, we get
Yes.
super overwhelmed in the depth. We're like, no, no, no,
Mhm.
get the surface level and you're probably good. But then when we see these reactions, just remember you just need the surface level. You don't need to do anything crazy. But again,
Yeah.
we'll get into that next episode. So yeah, I'm the exact same. I'm really excited to like really let people listening know what you actually need to know for OChem.
Yeah.
Mhm.
Especially because it's so scary. So we're gonna defeat the beast next episode.
Absolutely. Mhm.
Get excited. We're definitely excited. We've hoped you've liked our discussion today about ChemPhys. I hope you feel ready to go get some ChemPhys practice,
Mhm.
right? Never too early. Again, just as a note, I know a lot of us are prepping for 2026 test dates. That doesn't mean that you wait until you've learned everything before you do passages. Okay.
Mhm.
You now, by virtue of listening to this podcast, you have the basic strategies and skills needed to try a passage. Even if, like I said, our QBank is free. If you want to do a fundamental passage in OChem or physics or Gen Chem, do it, right? You don't want to stray too far from passages, even early on. Sure, is your accuracy going to be lower? Of course. But if you start to learn topics, like if you sit down and you're like, I heard your last episode on forces, energy, and power. Okay, I'm going to go do some practice questions on forces, energy, and power. Please do it, right? Don't let this information we've just talked about just sit in a dark corner of your mind and collect dust. Put it into action. That's the best way to get better. It's also the best way to remember the things that we've talked about. So,
Yeah, practice. I mean, I
little
think we even
plug,
I
practice.
talked about that like along like when we talked about like psych soc
Mhm.
like learning strategies. We did a whole
Active
episode on that,
recall.
the active
Yep.
recall. So 100% like if you're like, "Oh, hey, I need to learn some psych soc," but also like some really good study strategies, especially now during this time period where a lot of people are just starting and you want to start right. Highly recommend we check that episode out.
Yeah.
And so with that, thank you all. If you made it to the end of the episode, thank you for joining us this episode. Let us know if you like stuff like this because we'll be doing we'll be doing psych social. Let us know in the comments or send us an email and say, hey, you like the stuff. We read all the emails and I honestly like Molly and I were like whenever we get a really nice email we're like share it to
We
one another.
we
We're
we
like
share it with
oh
each other. We're like, oh my
look at
God.
this. Yeah,
Look at
so yeah,
this
let
one.
us know. Let us know if you like the episode and if there's some struggles that you feel like you have in psych soc or and bio that you want us specifically to address in those episodes. Let us
Mhm.
know in the comments, email us, and we'd be happy to do it. So with that, it's been a pleasure and happy studying, everybody.
Bye, everyone.
Welcome to the Jack Westin MCAT podcast with your hosts, Michael Maleka
And Molly Hudash.